Bismillahirrahmanirrahim. Bismillahirrahmanirrahim. How are you, students? Today we will study adiabatic and isothermal expansion. Page number 255, chapter number, unit number 10, class first year, lecture number 45. Before going into detail of isothermal process and adiabatic process, first we will revise the previous lecture. First we studied thermodynamics. The study thermodynamics is the branch of physics in which we study work, heat and energy on a system. Thermodynamics is only concerned with large scale of observation. Thermal equilibrium. When two different bodies at the same temperature. For example, we have two bodies. This is one containing liquid, this is the second body also containing liquid. If both are at 26 degrees Celsius, so these two bodies are said to be in thermal equilibrium. Thermodynamic equilibrium. Thermal equilibrium, zeroth law. If two systems are separated, found to be in thermal equilibrium, or separately found to be in thermal equilibrium with a third system, the first two systems are in thermal equilibrium. If these two bodies, this is third system, this is second system, this is first and second, this is first, this is second, this is second, this is third. If third object system is in thermal equilibrium with the second one, and the second one is in thermal equilibrium with the first one, then the first one is in thermal equilibrium with the third one. This is zeroth law. Temperature, the degree of hotness or coolness of a body is called temperature. It determines the direction of heat flow. Temperature is also a measure of average kinetic energy of a particle. Heat is invisible, weightless and can flow from one body into another body. Work, a form of energy which is equal to the product of force and displacement. Work is the mechanical energy and heat is the work are two different modes of energy. During these interaction, equilibrium is necessary for the equation to relate heat and work. Both are form of energy. Heat and work are two different ways of transferring energy from one system to another. The distinction between heat and work is heat is the transfer of thermal energy, and work is the transfer of mechanical energy. Now, system. Anything which is kept in consideration is called system. Surrounding, everything external to the system is known surrounding. Boundary, the thermodynamic system and the surrounding are separated by an envelope called boundary. This is boundary, this is surrounding, and this is a system. These are boundary of a system. Universe, when thermodynamic system and surrounding combines, it gives you the universe. When this system combine with the surrounding, it will give you the universe. Internal energy, the energy associated with the random disorder motion of molecules, are total kinetic energy, translational, rotational, vibration The sum of all types of kinetic energy and potential energy is called internal energy, represented by del U. Internal energy is the sum of kinetic energy and potential energy. This is first law of thermodynamics. Write it in a different way. Q is equal to del U plus W. When heat is given to a system, a part of this heat is used to increase the internal energy, and the rest of the energy is used to do work against the friction. Heat flow into the system, internal energy increases. Heat flow out of the system, internal energy decreases. Work done on the system, internal energy increases. Work done by the system, internal energy decreases. Now we will start the new topic. Now this is the revision. Isothermal process. An isothermal process is a thermodynamic process in which the temperature of the system remains constant. Temperature is constant. Temperature is equal to constant. Temperature is constant, during which the pressure is kept constant. If pressure is kept constant, then the process will be isobaric. The transfer of heat into or out of the system happens so slowly that thermal equilibrium is maintained. If heat is taken from the system, it will take heat from the surrounding, from the reservoir, heat reservoir, or otherwise it will release. When graph is plotted between pressure and volume, when the temperature is constant, the graph is this line. This is for isothermal. Now this is graph for isothermal between pressure and volume. Since for an ideal gas the internal energy is proportional to the temperature, it follows that there is no change in the internal energy of the gas during an isothermal process. So when there is no change in isothermal energy and the internal energy, because temperature is constant, so isothermal energy will be, internal energy will be equal to 0. So write del Q is equal to del U plus W. So del Q is equal to 0 plus W. Del Q is equal to W. So the heat provided to a system is used to increase the internal energy of the system. Isothermal process is a change of a system in which the temperature remains constant. Typically occurs when a system is in contact with an outside thermal reservoir, heat bath, and change occurs slowly enough to allow a system to continually adjust the temperature of the reservoir through heat exchange. So now the next topic is adiabatic process, in which no heat enter or leave the system. No heat enter or leave the system. No heat enter or leave the system. Del Q is equal to 0. So del Q is equal to del U plus W. So 0 del U plus W. So work is equal to minus del U. So work is done at the cost of the internal energy of the system. So in adiabatic process, del U is equal to minus del W. W is equal to minus del U. Minus del U. This means that if a system does the work, then in adiabatic process the work is done at the cost of the internal energy of the system. So the temperature drop. There is a drop in temperature. Now, adiabatic process. An adiabatic process is a process in which there is no thermal energy transfer. Q is equal to 0. A reversible adiabatic process involves worked expansion in which we can return all the energy transfer in case PV gamma is equal to constant. This is the Boyle law adopt this shape. PV gamma is equal to constant. All real processes are not adiabatic. Now, isothermal process versus adiabatic process. So first, an isothermal process is a thermodynamic process that occurs under a constant temperature. On the other hand, adiabatic process is a thermodynamic process that occurs without any heat transfer between a system and its surrounding. So no heat enter or leave the system, and here the temperature is constant. Now, heat transfer can be observed because to keep the temperature constant, sometime in isothermal process heat will be released and sometime it will be absorbed from the reservoir. Heat sink or high temperature reservoir. There is no transfer of heat because no heat enter or leave the system. The temperature is constant. The temperature can be changed. In adiabatic process, temperature change. In isothermal process, temperature remains constant. Work done is due to the change in the net heat contents of the system. Work done is due to the change in the internal energy. Now, consider a simple example, adiabatic process. An example of an adiabatic process is the vertical flow of air in the atmosphere. Air expands and cools as it rises, and contracts and grows warmer as it descends. Another example is when an interstellar gas clouds expands or contracts. Adiabatic change are usually accompanied by changes in temperature. Change in temperature will take place during adiabatic process. Change of temperature. Temperature will occur. Adiabatic expansion. This is the graph for adiabatic expansion. Here, state 1, gas is compressed, so temperature will increase. Here the gas expands, so temperature will decrease. So change of temperature occur in adiabatic process. Now, difference between isothermal and adiabatic process in another way with an example. Isothermal process, temperature remains constant. An isothermal process is a change of system in which the temperature of the system remains constant. An adiabatic process is one that occurs without transfer of heat or matter between thermodynamic system and its surrounding. In this system, no heat enter or leave the system. Here, change of temperature take place. Here, no heat can be given to keep the temperature constant. Heat can enter or leave the system in isothermal process. keep the temperature constant. To keep the temperature constant. Now, I will explain molar specific heat of a gas. Molar specific heat of a gas. Molar specific heat of a gas. Specific heat of a body is defined as the quantity of heat required to raise the temperature of 1 kilogram of substance through 1 Kelvin. For example, if you provide heat, the quantity of heat is called specific heat. Or molar specific heat. If it raises the temperature of a body of mass 1 kilogram through 1 Kelvin degree. If you want to brought a change of 1 Kelvin by heating a mass of 1 kilogram, then the heat given to such system is called is called specific heat. For example, if the mass of body is 1 kilogram and you give heat to it, this heat will be specific heat only if it change the temperature of a body of mass 1 kilogram through 1 Kelvin. Now, in mathematical form, del Q is directly proportional to the change in temperature, because we want to change the temperature through 1 Kelvin, and directly proportional to the number of to n. Now, del Q is equal to constant, which is C, molar specific heat, n del T, where C is a constant of proportionality and is known as molar specific heat or molar specific heat capacity. These are unit of molar specific heat or molar specific heat capacity is joule per mole per Kelvin. Joule per mole per Kelvin. The temperature of a gas may be changed under variety of conditions. The volume may be kept constant, or the pressure may be kept constant, or both may be varied in some definite manner. Thus, for a gas, two specific heat are defined: the molar specific heat at constant volume and the molar specific heat at constant pressure. So simply you can define as the quantity of heat required to raise the temperature of 1 mole of a gas by 1 Kelvin is called molar specific heat or molar specific heat capacity of that gas. If del Q is the amount of heat required to raise the temperature of a n moles of a substance by this one. This is number of moles. This is change in temperature. This is heat. So today we studied that isothermal process is the process in which the temperature is kept constant. Temperature is constant. So no heat must be not equal to 0. Heat can enter or leave the system. Adiabatic process in which no heat enter or leave the system. So temperature will change. Change of temperature will take place. Adiabatic process. That's the difference between. This is the curve for adiabatic process. The graph for isobaric process is if graph is plotted between pressure and volume for isobaric process. The graph will be a horizontal line. This is for isobaric process. isobaric process. Isobaric process. This is the Grappa isobaric process. The Grappa isochoric process is during which volume of the system remains constant. This graph bar is per vertical line per isochoric process isobaric. Thank you, students. Wish you best of luck. Do revise.